Okay, it started. Go ahead.
Okay, thank you. Okay, let me introduce the agenda of today's Harbor community meeting. We are working on the implement the Harbor OCI registry for Harbor. Today we will have Wen Kai-ying to introduce the progress of the OCI registry. And the second, as we know, we have released the Harbor version 1.10 in by the end of the last year. And there is a new feature, plugin scanner introduced in this release. And with this release, with this feature, Harbor users can have more options to scan their container images. And today we will have two plugin scanners to show. One is from Daniel Patrick from Aqua to introduce their CSP for Harbor container plugin scanner. And the second scanner plugin is from Guang Yuan from DoSec to introduce their implementation of the plugin scanner. And finally, we will introduce the Harbor community meeting up in 2020 February, Shanghai. Okay, let's please let's Wen Kai to introduce the progress of the OCI registry. Wen Kai, could you please take control of the screen? Share your screen.
I have no slide to share. Just share some status about the works.
Okay.
First, some background for the OCI works. There is a distribution spec defines the standard that the container registries should implement. Currently, most of the container registries can store and manage only the Docker images, but application and services typically require additional artifacts to deploy and manage, such as Helm-chart, CNAB, and all others. Utilizing the manifest and index definitions of the distribution spec, the container registry can be used to store and manage all these artifacts. The artifacts that follow the spec are called OCI artifacts. Harbor is one of the implementation of the distribution spec. So the OCI work of Harbor is that we will make Harbor to be able to manage any kind of OCI artifact. This is the background. For the development status, the UI design is finalized and the development work is started. For the backend side, the registry handler and artifact module is almost done. The basic pushing, pulling workflow works now. When you pushing image list or Helm charts into Harbor, the metadata can be abstracted and stored in database. Next, we will introduce some new APIs to list and operate this kind of artifacts and make sure all other existing features such as replication, quota, tag rotation, scan, immutable tags can work as expected. And after that, the garbage collection and upgrade works should be started. So during the development works, the code on master branch may be broken. So if you do some work based on that, you should notice this. Maybe next community meeting, we can do some basic demo for the OCI supporting based on the APIs. I think these are all the status about the OCI work. 道具。道具 can you hear me?
Yes. Hi, everyone. Let me share the screen. I will walk you through the additional scanner that you could configure in Harbor to check the vulnerabilities of your images. Yeah, I think we need to stop the previous screen share in order to enable me to share. Yeah. All right. At this point, you should see my screen. So I have Harbor 1.10 up and running. I'm running it on Minikube locally, just for the purpose of the demo. And I also have the Aqua CSP deployment up and running here. So just a little bit of context for those of you who don't know. So we in 1.10, we enabled the configuration of additional scanners to the default Claire. Right, so at Aqua, we implemented two additional image scanners. One is 3D, which is based on our open source 3D scanner. And another one is for Aqua CSP. Aqua CSP is a product which is not only for scanning, but also runtime protection. So we are enabling its scanning capability directly into the Harbor. So according to the specification, we provide the adapter, which implements the scanner API. And you can see that I have already installed the adapter on my VM. What is important for the adapter? All the installation guides, README prerequisites are, I think, well documented in README. We have actual customers using it and opening support tickets. Most of those are related to the configuration and setup, but it's, I would say, battle tested, but some of them. And we provide the Helm chart installation. So it's pretty easy. You just need to know the, obviously you need the license for the Aqua CSP product in order to run it. But we also require you to specify some additional information about the registry, an Aqua registry username and password, as well as Aqua CSP console and username. Those are documented, and everyone who's using and deploying Aqua in production should have those credentials from the Aqua documentation, or it's part of the installation package, right? So once we install the adapter, it's like for other scanner adapters, the REST endpoint, which is an intermediary between Harbor and the Aqua CSP product. Under the covers, the integration is pretty similar to 3D because there is a scanner CLI binary executable that we are spawning as a process within the adapter container in order to trigger the scan and submit the results. Right, so I think when it comes to the installation and setup, that's it. The most important thing is to have the dedicated user for scanning. And as you can see, I have already created the scanner user, and it needs a role. He's granted the scanner role. And another thing, in order to enable the scanning and pluggable scanners experience, is the integration with Harbor. So we also have the Harbor registry integrated and configured here. I could also test that connection. My setup is at HTTPS core Harbor domain, whereas my console is accessible at let me see. My console is accessible by default at this URL, right? As I said in the beginning, I have all the software, including the Aqua CSP product, the Aqua scanner adapter, and the Harbor itself deployed to Minikube locally. So now, as you might know, we could choose a given adapter as a default one. So whenever we go select a repository and the project, I'm always double checking here. Yeah, it's also Aqua CSP here, inheriting the default setup. So if I go and try scanning the Photon OS, And just to give you a proof that it's scanning, let me stream the logs of the adapter. And so when I scan, I think we are on the very, I think we're just logging the errors, so it's not verbose output, but as you can see, the scan succeeded. And we have the list of vulnerabilities that Aqua CSP found displayed in Harbor UI. Right, we can try with some other, let's scan Jenkins, just to show you that on top of scanning the operating system packages, we could also scan application dependencies. Jenkins is implemented in Java, and it's using lots of Apache Commons and other third-party application dependencies. So Aqua CSP has a feature of scanning those, and we also display such vulnerabilities in Harbor.
While that's happening, Daniel, does Trivy also scan Java packages, or is this a specific feature to CSP since that's your bigger platform?
Trivy does support application dependencies scanning. Unfortunately, currently we do not support Java, but we support NPMs, I believe Ruby on Rails, but we are planning to integrate it very soon. But for the Java applications, you only this capability is only with a commercial Aqua CSP, right? So as you can see, we could find some of the operating system packages. Unfortunately, when we defined the scanner API, we didn't distinguish from application dependency package. So they are both displayed here, and maybe sometimes hard to find, but you can tell, for example, here, right? This vulnerability is pointing to the webinf, so the standard location for WAR files, for those who know Java. So as you can see, there is a Jenkins core, and we found the vulnerability right here. Yeah, so I think that's it. If you have any questions, one maybe last comment, all the scans that we triggered from Harbor, we could also check in the console right here, right? So Aqua CSP has its own vulnerability reporting, which is, let's say, more advanced because you could display vulnerabilities by layer, by resource, and some other features. But just to let you know that we could see them in both places, right? So yeah, that's it from my side. I hope I didn't miss some important points.
No, that's perfect. Thank you. Thank you first of all for the work that you guys did in spearheading this effort, and this is great integration. We love to see more and more things coming from your side of the world and Aqua. Thank you.
Yeah, thank you.
Thank you, Daniel. Next, we will have Shuguang Yuan from DoSec to introduce their plugin scanner. Shuguang, could you please share your screen?
Okay, can you hear me?
Yeah.
Okay, I'll share my screen. Wait. Is this okay?
Yeah.
Okay, now I'll begin. Hi everyone, I'm Vanke from DoSec, and today I'll talk about DoSec image scanner for Harbor. It will take about 10 minutes. Well, by the way, this word reads DoSec. It's short for Do Security, and our scanner doesn't have a nice name yet, so I'll call it a DoSec scanner temporarily. Okay. Well, first I'll introduce the deployment architecture. Well, on the left side is Harbor and the registry, and on the right side is DOSEC scanner. Well, let's see how a scan job works. The first, Harbor will send a job and a token to the adapter API, which is implemented by the DOSEC scanner. And then scan engine will use this token to fetch layers from the registry. And well, this third is scan the image and store the result in database. Well, this database contains 3 types of data, CVE and CNVD, and the scan result. By the way, this CNVD is short for China National Vulnerability Database of Information Security. Okay, next page. Well, I'll briefly introduce the implementation of scanning. Well, image is design layered, so our scan engine will treat every image as a group of layers, and it iterates all over each layer and detect the package diffs in it. You can treat this diff like a Git diff, you know, and it will merge all diff at an and generate a complete list of installed packages in image. With this list, it queries the database and link each package with vulnerabilities, and that's a whole scan job. And if next time someone add a new layer to this image, the scan engine only needs to download the newest layer and detect the diff, then query the database. Well, that's a benefit of layered scan. Okay, now let's do some demo. Okay, this is our project on GitHub, and I'll follow the install steps. First, download an offline install package, then run an install shell. It will be installed. It's really simple. And then configure Harbor. Let me introduce the configuration. Well, this config file is for Docker Compose, and there are 3 images in it. The first is the database, and the second is the adapter API, and the third is the scan engine. Well, what you need to care about is this port. The first port will expose the 2 hosts, and the second one you can't change because it's hard code. So this one you use in Harbor UI, and this is a log directory which will be mounted on host, and this is inside the container. If something goes wrong, you can check every log here. And the DOSEC scan. Oh, okay. If you want auto updating CVE database, you should uncomment this line to enable this feature, and it will update daily. Yes. Okay. Now I've already downloaded the offline install package, and there are three files in it. The first, let me check the installer shell. Well, it's a simple shell. It's first it detects if Docker was started, then it uses Docker load the image in this zip file, and lastly it used Docker Compose to start the image. And I've already loaded the image, so I'll edit the config file here. I change this port to 5001 and then use Docker Compose, start it. Well, you can use Docker Compose top to verify if they are already started. Okay, there are three containers running. Now let's configure it in Harbor. Well, okay, this one can't be used anymore because I've changed the port. I'll edit it, change the old port to new one. Well, this IP is the host I just used, and if you deploy the DUSEC scanner to another host, you need to write its IP here. And these options are not necessary. Just test connection. Well, I'll save it. Okay, I think it's fine, this thing. Well, the database update on December, well, just just 3 weeks ago. And we'll update the offline package monthly for now. So if you don't want the auto updating, you can just download our offline package periodically to update the CV database. Now let's scan an image. Well, here I choose this Ubuntu image. Okay, it's already been scanned. Let's scan it again. Okay, here comes the result. It has a summary severity of medium and 30 total vulnerability, 6 fixable. Let's check the details. Okay. You see each CVE ID is followed by a CNVD ID, and the descriptions are Chinese. So this scanner is mainly for Chinese user, I think. And as for this CVE, they have no CNVD ID because they haven't recorded into the CNVD database. Oh, sorry. Maybe it's too new, but there is a delay between the CV database and the CNVD database updating. So I think most cases are fine. That's all. Thanks.
Thank you, Wang. It's impressive demo.
Thanks.
Thank you. Any questions?
Yeah, I have looked at it, but we have 1 minute left, so I want to mention we'll have the Harbor Community Meetup at Shanghai in February 22. So we have 2 slots for sharing your use case of Harbor. So if you want to share your use case of Harbor use case in your company in that meetup, please contact us.
Okay. The other thing we have to mention that is that the next weekend is the Chinese Spring Festival. Happy New Year to all. And during this time, the Harbor community meeting will be canceled in the next 2 weeks. And the next Harbor community meeting will be scheduled to the middle of February. Thank you for joining the meeting.
Thank you for hosting it, Dajun. Have a great day.
Thank you.
Have a
Bye.
good day. Bye-bye.
Bye.